In this video, we will be solving a few more proof type questions. I've taken these questions from the Maharashtra government textbook, Maths Part 1, 11th Standard, Chapter 2, Miscellaneous Exercise. And like I've said in the earlier video also, that you need not be from the state board only to answer these questions. No matter whichever board you belong to, you will find these questions in some or the other corner of your textbook. These are very standard questions. So even if you are in 11th standard from some other board, these questions are going to really help you. So in case if you have missed my last video, you can find the link in the description box below. And yeah, with that, we'll begin with the questions. So here's the first question. All these are questions that you need to prove. So you need to prove that this entire left hand side will be equal to 1. That's what we need to prove. So we begin with our left hand side. On the left hand side, we can consider this term and this term to be together. From the two terms, we can take out sine square a common. In the bracket, we will have cos square b plus sine square b. Then from the two terms here, we can pull out a cos square a common. So we have plus cos square a into sine square b plus cos square b. Now cos square b plus sine square b will be 1. Sine square b plus cos square b will also be 1. So we are finally left with sine square a into 1, which is sine square a, plus cos square a into 1, that is equal to cos square a, and then sine square a plus cos square a will be equal to 1, which is equal to your right hand side. So that is how we are proving our or solving our first question. The second one, yeah, proving there is an appropriate word. That is how we are proving our questions. So go ahead with the second one. Now in the second one, you see a lot of terms there which are very troubling. Cot theta, tan theta, there's a sec cube theta, cosec cube theta. When you find these kind of troublesome terms in front of you, always convert everything to sine and cos and your job will be done very easily. So we have 1 plus cot theta is cos theta upon sine theta. Just for a shorter terminology and to save time, I am writing this kind of expressions. But in your exams, you should write full cos theta and sine theta. Plus tan theta would be sine theta upon cos theta. Sine and cos, let them remain the way they are. Divided by the denominator will be sec cube theta is 1 upon cos cube theta minus 1 upon cosec cube theta is 1 upon sine cube theta. Let's combine the two terms here. If we are combining these two terms, then that would become cos square theta plus sine square theta upon sine theta cos theta. It's like just cross multiplying and adding the fractions. Okay, so that's cos square plus sine square upon sine cos. But cos square theta plus sine square theta is 1. And finally we have, okay, if you combine the two terms here, it would be sine theta cos theta plus 1 divided by sine theta cos theta. Now you can actually write this 1 as sine square theta plus cos square theta. And just imagine the entire expression. I only want you to take a look at the numerator. Okay, this part. That part is like a minus b. And then you have in this bracket a square plus b square plus ab. When we talk about a minus b into a square plus ab plus b square, that is basically the expansion of a cube minus b cube. So in the numerator, what you have is a cube minus b cube, this entire term. That entire term is a cube minus b cube, and that is why we can write it as sine cube theta minus cos cube theta. Do not forget the denominator, that was sine theta cos theta. And then the entire thing's denominator is 1 upon cos cube theta minus 1 upon sine cube theta. You can simply cross multiply, or what I precisely mean is you can subtract the two terms here, just like you are subtracting fractions, which will give you a sine cube theta minus cos cube theta in the denominator, and there will be a sine cube theta cos cube theta in the denominator's denominator, which actually goes to the numerator, and you get sine cube theta into cos cube theta in the numerator. Now that sine cube theta minus cos cube theta term gets cancelled, and you are left with sine cube theta into cos cube theta upon sine theta cos theta. One sine theta cos theta in the numerator gets cancelled, and you are left with sine square theta into cos square theta, and that term is what you have as your right hand side. So that is how you can prove this second result, or this second question, whatever you call it. Okay, let's go ahead with the third one. we again begin with our left hand side only, and the best thing is convert everything to sine and cos. So we can write the tan theta as sine theta upon cos theta. Tan theta here will also be sine theta upon cos theta. And finally the expression is sine upon cos plus 1 upon cos. So that is like sine theta plus 1 the whole upon cos theta. Sine theta minus 1 the whole upon cos theta. So here's what we have our left hand side as sine theta plus 1 upon cos theta the whole square plus sine theta minus 1 upon cos theta the whole square. Expand the numerator as a plus b the whole square. Sine square theta plus 2 sine theta into 1, which is 2 sine theta only, plus 1 upon cos square theta, plus we have sine square theta minus 2 sine theta plus 1 upon cos square theta. You add up the terms and you will realize that this plus 2 sine theta minus 2 sine theta gets cancelled. So the left hand side now is sine square theta plus sine square theta, which is 2 times sine square theta, plus 1 which is equal to 2. So that's 2 sine square theta plus 2, which is 2 times sine square theta plus 1, divided by cos square theta can be written as 1 minus sine square theta. So now that is ultimately what you had to prove. This is your right hand side. Just the numerator, which I have written as 2 into sine square theta plus 1, they have given it as 2 times 1 plus sine square theta. So ultimately this is the method by which you can prove the third result also. Third expression. Okay, I'm not getting the right word for that, but that's how we are solving the third question. Let's go ahead with the fourth one. On the left hand side it is 2 times sec square theta minus sec power 4 theta minus 2 times cosec square theta plus cosec power 4 theta, and that should be equal to cot power 4 theta minus tan power 4 theta. Okay, I'm not very sure about how would I go ahead in this, but fine. I'm seeing a sec square theta common with the two terms here and a cosec square theta common with the two terms there. So I am taking out a sec square theta from here. That would give me 2 minus sec square theta. I am pulling out a minus cosec square theta from the last two terms as well. So that would give me 2 minus cosec square theta in the second bracket. Okay, we can write that sec square theta as 1 plus tan square theta. You need to understand that there is a minus here. So when you open up the bracket, it would be minus 1 minus tan square theta. And cosec square theta here also we can write it as 1 plus cot square theta. We will do it with the terms here as well as here. That is, this term will be 1 plus tan square theta and this term would be 1 plus cot square theta. Okay, so let's do that and check what we are getting. It's 1 plus tan square theta. 2 minus 1 minus tan square theta is 1 minus tan square theta. Okay, so I guess we are done with the solution. This would be 1 plus cot square theta. Expand the bracket here, that would be 2 minus 1 minus cot square theta, that is 1 minus cot square theta. And finally this is like a plus b into a minus b. That would give you 1 minus tan power 4 theta minus, again here it is a plus b into a minus b. Keep those terms in the bracket only, because after that we will be opening up the bracket along with the minus sign. So this would be a square minus b square, that is 1 minus square of cot square theta, which is cot power 4 theta. Open up the bracket, so this would give you minus 1 and a plus here, and that finally turns out to be cot power 4 theta minus tan power 4 theta, because that plus 1 and minus 1 are getting cancelled. Yeah, so that's the right hand side, and that's how we are proving our fourth expression. Let's go ahead with the fifth one. On the left hand side, all we have is sine power 4 theta plus cos power 4 theta. It's a very simple question because we can write the first term as sine square theta the whole square, plus second term would be cos square theta the whole square. Add 2 sine square theta cos square theta and subtract the same term. So the first three terms are forming the expansion of sine square theta plus cos square theta the whole square minus 2 sine square theta cos square theta. This would be 1, the square of which would also be 1. So this becomes 1 minus 2 sine square theta cos square theta, which is equal to your RHS. That's how we are proving the fifth result, the fifth expression, the fifth question, whatever you call it. Okay, let's go ahead with the sixth one. 2 times sine power 6 plus cos power 6, I should say sine power 6 theta plus cos power 6 theta. 3 times sine power 4 theta plus cos power 4 theta plus 1, and we need to prove that the entire expression's value would be 0. It's a simple one because all you need to do is on the left hand side 2 times. This is like a cube plus b cube, where your a and b are sine square theta and cos square theta. The sine power 6 theta is like sine square theta the whole cube. So a cube plus b cube, we can apply the formula of a plus b. So 2 times a plus b, that is sine square theta plus cos square theta, into a square, that is sine square theta the whole square, which is sine power 4, minus ab, that is minus sine square theta cos square theta, plus cos square theta the whole square, that is cos power 4 theta, minus 3 times sine power 4 plus cos power 4 theta, plus 1. So now this term becomes equal to 1. So we can just cancel it off and simply write it as into 1 into this. And let's expand the bracket. So we have 2 sine power 4 theta minus 2 times sine square theta cos square theta plus 2 cos power 4 theta minus 3 sine power 4 theta minus 3 cos power 4 theta plus 1. Okay. Minus 2 sine power 4 minus 3 sine power 4 is minus sine power 4 theta plus 2 cos power 4 minus 3 cos power 4 is minus cos power 4 theta, and then we have minus 2 sine square theta cos square theta plus 1. You can pull out a minus common from here, and when you do that, whatever you have inside the bracket is sine power 4 plus cos power 4 plus 2 sine square theta cos square theta, and that represents the expansion of sine square theta plus cos square theta the whole square. You know that this would be 1, the square of which would be 1. You have a minus sign outside here. So the value for this first term would be minus 1 plus 1, and that is indeed equal to 0, which is equal to your RHS. Yeah, so that's how we are proving the 6th question. Cos power 4 minus sine power 4 plus 1 should be 2 cos square theta. Okay, I might not be saying theta, but you need to know that it's not the correct way. There has to be a theta there. Apologies for the mistake that I'm making, but that disclaimer is right here. You need to pronounce it fully as cos power 4 theta. Just to be a little quick, I might skip pronouncing that theta, but you need to understand that it needs to be mentioned and it needs to be written also. You can't just write a cos power 4 and leave it just like that, because cos power 4 exists for an angle theta. So cos power 4 theta, the full thing needs to be written while you are writing your papers. Yes, so let's go ahead with this. It's like a square minus b square, where your a and b are cos square theta and sine square theta. So this is like cos square theta the whole square minus sine square theta the whole square. And I can write it as cos square theta minus sine square theta into cos square theta plus sine square theta. So cos square theta plus sine square theta would be 1. So we can write this as 1. So we have cos square theta minus sine square theta plus 1. It is this one that I have written here. And finally this 1 you can write it as sine square theta plus cos square theta. So you are cancelling off the sine square theta here. And cos square theta plus cos square theta is 2 cos square theta. And that is what you have on your right hand side. Yeah, so that's the 7th question. Let's go ahead with the 8th one. Sine power 4 theta plus 2 sine square theta cos square theta. You can simply pull out a sine square theta common from the two terms on the left hand side. So sine square theta bracket, in the bracket we will be left with sine square theta plus 2 times cos square theta. And because we need everything in terms of cos power 4 theta, or because we have everything in terms of cos, let's convert this sine square to cos square by writing it as 1 minus cos square. Even this we will write it as 1 minus cos square theta. So 1 minus cos square theta plus 2 times cos square theta. This is 1 minus cos square theta into 1 minus cos square plus 2 cos square, which is equal to 1 plus cos square theta. A minus b into a plus b would be a square minus b square, that is 1 minus cos power 4 theta, which is equal to your right hand side. Yeah, so that's how we are proving the 8th question as well. Let's go ahead with the 9th one. So in the numerator you have a cube plus b cube. The formula for a cube plus b cube is a plus b, that is sine theta plus cos theta, into a square plus ab plus b square. Sorry, the middle term would be minus. Okay, and in the denominator it is sine theta plus cos theta plus the second term a cube minus b cube, so that would be a minus b, a square plus ab plus b square, the whole upon sine theta minus cos theta. It's very clear that these two terms are getting cancelled here, and then these two terms getting cancelled here. In the remaining brackets there's a minus sine theta cos theta plus sine theta cos theta getting cancelled. Sine square theta plus cos square theta, that's making it 1. Sine square theta plus cos square theta is making it 1 on the right as well. So you have the value for this entire expression as 2, which is equal to your right hand side. And yeah, that's how you're solving the 9th question. The 10th one, okay, on the left hand side you have tan square theta minus sine square theta. Let's write it as sine square theta minus cos square theta minus sine square theta. Pull out a sine square theta common, it will be 1 upon cos square theta minus 1. And okay, 1 upon cos square theta would be like sec square theta minus 1. And then sec square theta minus 1 is tan square theta. So this is sine square theta into tan square theta, but tan square theta is sine square theta upon cos square theta. Sine square theta into sine square theta is sine power 4 theta. The denominator's cos square theta can be written in the numerator as sec power 4 theta. Yeah. So that's what you have on the right hand side, and that completes your 10th question. Sin theta plus cosec theta the whole square plus cos theta plus sec theta the whole square, and we need to prove that that is equal to tan square theta plus cot square theta plus 7, that weird looking term. Okay, let's begin and let's see how do we get that 7 from solving the left hand side. It is sin theta plus cosec theta would be 1 upon sin theta the whole square, plus we have cos theta plus 1 upon cos theta the whole square. Okay, so if we club the two terms here, that would be sin square theta, sin square theta plus 1 upon sin theta the whole square, plus we have cos square theta plus 1 upon cos theta the whole square. Well, should we just expand the bracket in the numerator? I guess that might help. Let's give it a try. So we have sine power 4 theta plus 2 times sine square theta plus 1 upon sine square theta, plus we have cos power 4 theta plus 2 cos square theta plus 1 upon cos square theta, and then we can simply add the two fractions here as well. That would give us sine power 4 theta into cos square theta plus 2 sine square theta cos square theta plus cos square theta plus cos power 4 theta sine square theta plus 2 cos square theta sine square theta plus sine square theta, the whole divided by sine square theta cos square theta. For all those who didn't get it, I have simply cross multiplied, and that gives me the terms in the numerator, and the denominator will be containing the two terms here, the multiplication of them. Okay. Okay, let's see what happens here. Sine power 4 into cos square plus cos power 4 into sine square. Now see, you need to understand that sine power 4 into cos square plus cos power 4 into sine square. You can pull out a sine square cos square common from the two of them, and that would make you leave, that would just simply give you sine square theta cos square theta into sine square theta plus cos square theta, but this would be 1. This would be 1. So the final expression, the final value for this expression would be sine square theta cos square theta. Okay, so that is what we will replace this term with. This would simply be sine square theta cos square theta plus, do we have anything else? Yes, we have cos square theta plus sine square theta. That should be equal to 1. So we have a plus 1. 2 sine square theta cos square theta, 2 sine square theta cos square theta, and 2 sine square theta cos square theta. That would be 5 times sine square theta cos square theta. Okay, so we have 5 times sine square theta cos square theta, and then we have a plus 1 here. What can we do with that 1? Should we simply write it as... Yeah, I think it's best we write it as sine square theta plus cos square theta, or we might not get a 7. Okay, yes, we have got our answer, because now if this is what you have, you can just split the numerator and denominator. So the first term would become 5 times sine square theta cos square theta upon sine square theta cos square theta, which is simply equal to 5, plus sine square theta upon sine square cos square theta upon sine square cos square. Cancel off that sine square here. So you get 1 upon cos square. Cancel off the cos square here. You get 1 upon sine square. 1 upon cos square theta is sec square theta. Plus 1 upon sine square theta is cosec square theta. Sec square theta is 1 plus tan square theta. And cosec square theta is 1 plus cot square theta. Yeah, so with that you have your answer, because this finally just turns out to be 5, 1 and 1, which is equal to 7 plus tan square theta plus cot square theta, and that is what exactly you have on the right hand side here. Okay, so that's how we are proving our 11th question, and let's go ahead with the 12th one, which must be as easy as the previous questions. Sine power 8 theta minus cos power 8 theta. Think of it as sine power 4 theta the whole square minus cos power 4 theta the whole square. That's like a square minus b square. So this is a plus b into a minus b. In a similar way, you can split this bracket and say that it is sine square theta minus cos square theta into sine square theta plus cos square theta. But this term will be equal to 1. Okay, so it's okay if we don't write it. The expression we finally have is this. Now to simplify this expression, I guess we can actually simplify this term, because we can write it as sine power 4 plus cos power 4 plus 2 sine square cos square minus 2 sine square cos square into, we already have sine square theta minus cos square theta. The first three terms are basically sine square theta plus cos square theta the whole square. But sine square theta plus cos square theta is 1. So the first term is 1 square, and we have 1 minus 2 sine square theta cos square theta as the value for the first bracket into sine square theta minus cos square theta. Can we do anything more than this now? We had to stop it here, and somehow we are not able to stop it there because we are having this. Okay, we have it over here. Yeah, so we have already proved that we have already proved what we had to prove, because the right hand side basically starts with this. So on the right hand side you had sine square theta minus cos square theta into 1 minus 2 sine square theta cos square theta, and that's entirely the value of your left hand side. Yeah, so that's how we are proving our 12th question. Let's go ahead, the 13th one. The left hand side says sine power 6a plus cos power 6a. It's like sine cube a the whole square, I'm sorry, sine square a the whole cube plus cos square a the whole cube, and then we can apply the formula of a cube plus b cube, which is actually a plus b. So sine square a plus cos square a into a square minus ab plus b square. Okay, this would be 1. So we have 1 into the entire bracket. This is 1 into the entire bracket here. The second bracket we can write it as sine square a the whole square plus 2 sine square cos square plus cos square a the whole square. I know you are wondering why have I done this, but I would actually balance it by writing a minus 3 sine square a cos square a in the end, because when I do that, the first three terms are actually becoming sine square a plus cos square a the whole square. That is 1 square, which is equal to 1. So we finally have 1 minus 3 sine square a cos square a. And yeah, that's what you had on the right hand side right here. So that's how we are proving our 13th question. And we can go ahead now with our 14th question. It's a very simple one. All you have to do is a plus b the whole square and a minus b the whole square. Expand the bracket and your work is done. So it would be 1 plus 2 tan a tan b plus tan square a tan square b plus we have tan square a minus 2 tan a tan b plus tan square b. You need to realize that this plus 2 tan a tan b and minus 2 tan a tan b get cancelled. 1 plus tan square a tan square b is one term, plus tan square a plus tan square b is the other term. We will prefer to combine 1 and tan square b, that is we will write them together. So we have 1 plus tan square b, write it in one bracket, plus from the two terms here, pull out a tan square a common. So we have tan square a into 1 plus tan square b. Now there are two terms from which you can pull out 1 plus tan square b common. So this becomes 1 plus tan square b into 1 plus tan square a. This becomes sec square b multiplied by the second term, which is sec square a. And yeah, that is precisely what you had to prove. Okay, so here's where you have your right hand side, and that completes the 14th question. Okay, the sum involving three terms of trigonometric identities. So here it is very clear that we need to use the result. Cot square theta plus 1 would be equal to cosec square theta. Take that 1 on the right. So you have cot square theta is cosec square theta minus 1, and you can write cot square theta as cot theta into cot theta. Cosec square theta minus 1 can be written as cosec theta plus 1 into cosec theta minus 1. Let's check the denominator. We need a 1 plus cosec theta in the denominator. So I think we will try to keep 1 plus cosec theta in the denominator of the left and bring 1 cot theta in the denominator on the right. So we will have cot theta upon 1 plus cosec theta. Cosec theta or 1 cosec theta plus 1 or 1 plus cosec theta is one and the same. That should be equal to, on the right hand side we have cosec theta minus 1 upon cot theta. Okay, now here's where we are using the theorem on equal ratios. For all those who know it, you can just fast forward the video a little bit and continue with this question. For all those who don't know it, here's where I am discussing it. Say for example, you are given that A upon B will be equal to C upon D. Then theorem on equal ratios will tell you that, theorem on equal ratio tells you that this ratio is in turn equal to A plus C upon B plus D also. Think of it as you are adding these numbers horizontally. Okay, not very accurate choice of words, but it just explains the idea. You are adding up the numbers horizontally. So when you do that, you get A plus C and B plus D, and that ratio which you just got will be equal to the original ratio of A upon B and C upon D, which were actually equal to each other. So if A upon B is equal to C upon D, then you can add up the two numbers and claim that you will have A plus C upon B plus D, and that ratio will in turn be equal to the original ratio. You can even subtract the numbers if you want. Okay, so that is the theorem on equal ratios, and yeah, this is the theorem that we will be using for solving this question. So now if you check in the denominator here, you need 1 plus cosec theta minus cot theta. So the right thing to do here would be, okay, let's just copy down this much part on a new page. So if you realize, then in the question you wanted 1 plus cosec theta minus cot theta in the denominator. So what we can do is 1 plus cosec theta minus cot theta. So we are actually subtracting the numbers, and we are subtracting left hand side minus right hand side. Okay, so left hand side minus right hand side, that would give you cot theta minus cosec theta minus of cosec theta minus 1. So when you open the bracket, it would be minus cosec theta plus 1 divided by 1 plus cosec theta minus cot theta. I am sure you will tell me that, okay, we have got the denominator, but is our numerator in the way we wanted it to be? The numerator is cot minus cosec plus 1. Let's check it in the question. Cot, okay, it's not minus cosec and plus 1, but let it just remain the way it is, and let's focus currently on the right hand side's denominator, and let's try to bring it in our expressions, and maybe then we can do something about it. Cot theta minus cosec theta plus 1. Cot theta minus cosec theta plus 1. Okay, that would be a little difficult to get. Okay, we can get it in the numerator. Cot theta, okay, we have it already in the numerator here. So we need to look at the other terms now. So let's try looking at this term. cosec theta plus cot theta minus 1. Cosec theta plus, okay, so cosec theta plus cot theta minus 1. We can get it if we are adding up the numbers here. So just add them up and you will have cot theta plus cosec theta minus 1 divided by 1 plus cosec theta minus cot theta. Sorry, plus cot theta. We have basically added the two numbers here. Okay, and the claim is that the ratio that we have got is equal to this as well as this. Ultimately, we are concluding that these two ratios are equal amongst themselves. That is cot theta minus cosec theta plus 1 upon 1 plus cosec theta minus cot theta, that is equal to cot theta plus cosec theta minus 1 divided by 1 plus cosec theta plus cot theta. Now see, what you have to do is you just have to take this term on the left hand side in the numerator and take this term on the right hand side in the denominator. When you do that and just check the terms, you will realize that whatever you had to prove in the question has already been proved. So that is the way you can solve these type of questions. It went a little bit too long in this question, maybe because I made a slight mistake here. It's not really a mistake because we are definitely reaching the answer, but maybe, I'm not too sure about it, but maybe the sum would have been shorter had I taken cosec theta minus 1 in the denominator of the left hand side. That checking work you can do by yourself, but for now, yes, this is one of the methods which is available. Whether it will be shorter or no by taking this on the left, I am leaving that checking work up to you guys. Let's take one more question. It's a similar one. Now, because it's a similar one, I'm sure we can be a little quicker in this. Tan theta, okay, we have to use the identity 1 plus tan square theta equal to sec square theta. Okay, here this S stands for sec. There is no sine term in this particular question. So do not get confused with my terminology. 1 plus tan square theta is sec square theta. So tan square theta would be sec square theta minus 1. Sec square theta minus 1 would be sec theta plus 1 sec theta minus 1. And tan square theta would be tan theta into tan theta. Because we need sec theta plus 1 in the denominator, we can take sec theta plus 1 from here in the denominator of the left hand side. So upon sec theta plus 1 is what we have here. And 1 tan theta, we will take it on the right here. Okay. So we have tan theta equal to sec theta minus 1 upon tan theta, and by theorem on equal ratios this should be equal to, we need tan plus sec minus 1 in the numerator. So tan plus sec minus 1, basically we need to add the numbers. So if you add the numbers horizontally, that should give you tan theta plus sec theta minus 1 upon sec theta plus 1 plus tan theta, and yeah, open up the brackets here. And this is what you have on the left hand side. So ultimately from this entire equality you can see that this entire expression, which is basically this, is equal to this expression which is there on the right hand side. So that is how we are proving the 16th one. Much shorter than the previous one, but the method remained the same. That is, you had to use your identity. Now here, should that be an identity? I guess, yeah. I think we should convert these to sine and cos, and then our sum will be easier. So we have to actually prove that. Of course, we have to prove this equal to this, but let's write that left hand side in terms of sine and cos. So we have 1 upon sine plus cos upon sine minus 1 divided by 1 upon sine plus cos upon sine plus 1. That should be 1 minus sine theta upon cos theta. In the numerator we can, the numerator and denominator, we can multiply it throughout with sine. So we will have 1 plus cos minus sine, and in the denominator we will have 1 plus cos plus sine. Okay. So we have to prove that this relation is true. And now to prove this relation, we are very clear with our result. We will use sine square theta plus cos square theta equal to 1. The question is, should I take cos square theta on the right or sine square theta on the right? Because we have a 1 minus sine theta that is required on the right hand side, we will take sine square theta on the right, and that would give us cos square theta is 1 minus sine square theta. 1 minus sine square theta would be 1 minus sine theta into 1 plus sine theta. Keep that 1 minus sine theta in the numerator. Take that 1 minus sine theta in the left hand side and take it in the denominator. Even cos square theta would be cos theta into cos theta. So we will bring 1 cos theta on the right as well. With all that, we have cos theta upon 1 plus sine theta, which went on the left hand side's denominator, and cos theta, which comes in the denominator of the right. So 1 minus sine theta upon cos theta. By theorem on equal ratios, this entire term should be equal to, keep in mind we need 1 plus cos minus sine. We can get it if we are adding the numbers horizontally. So we add the numbers horizontally, we have cos plus 1 minus sine upon 1 plus sine plus cos. And yeah, we have proved it, that this result is true. That is, we have proved this particular result, and proving this result is enough to prove that this result is true. So that is how we are proving this particular question. And with that, let's go ahead with the next one. It's pretty clear that you have to go ahead with 1 plus cot square theta equal to cosec square theta. Unfortunately, both the terms are starting with C, so I will have to write the entire cot theta and cosec theta so that we understand the full thing. Now we can take that 1 on the right, so that would give us cosec square theta minus 1, and then we can write this as cot theta into cot theta equal to cosec theta plus 1 into cosec theta minus 1, and then cosec theta minus 1 you can take it on the left hand side. So cot theta upon cosec theta minus 1, take that cot theta on the right, and you have upon cot theta right here. And yeah, we need to prove that this expression, well, the expression we have is basically this. So we need to prove that this expression is equal to something, and that expression is equal to this. So we can get this expression if in the numerator we add up the two terms horizontally. So by theorem on equal ratios, we can say that this ratio is equal to this, and that ratio in turn will be equal to cot theta plus cosec theta plus 1, the whole divided by cosec theta minus 1 plus cot theta. Check carefully, it is very much equal to the expression that you have on the left. So this expression, which is equal to this, had to be proved equal to this, and we have proved that yes, it is indeed equal to this expression. So that is how we are proving the 18th question. Yeah, we are done with all the sums from the miscellaneous exercise, but I've taken one last sum in this video because in the previous video while editing, I had cut this question by mistake. So for all those who are regularly watching this video or regularly watching this video series, I'm doing the sum in this video so that whatever we had skipped in that last video gets covered in this one. So we have 1 plus, we can write cosec square theta. This cosec square theta can be written as 1 plus cot square theta. So if I write it as 1 plus cot square theta, and then finally if we expand the bracket, be careful, there is 3 cot square theta to be multiplied with both the terms here. So we will have 1 plus 3 cot square theta plus 3 cot power 4 theta plus cot power 6 theta. Now you need to realize that if you consider cot square theta as x, this is like 1 plus 3x plus 3x square plus x cube, and that basically represents the expansion of 1 plus x the whole cube. Okay, so the entire expression is like 1 plus cot square theta the whole cube, but 1 plus cot square theta is cosec square theta, and the cube of cosec square theta will be cosec power 6 theta, which is very much what you have on the right hand side. And yeah, that's how we are proving the 11th question. And yeah, this is where I'm done with whatever I wanted to discuss in this video. I hope whatever I've discussed has been somewhere helpful to you in your preparations. Thank you for watching.